process, we can call it as a capable if it is meet some certain criteria. What criteria is that? Let's discuss about that in this video.
In the previous video, we already discussed about the statistical process control. In statistical process control, we use the control chart to signal us, to give us a know about when the process is out of control, when there is an anomaly occur. Here, in this video, we will continue further with the topic related with the process capability. How capable the process is, let's see in detail about that in this video. The process capability, when we discussed in the previous video that the natural variation of process should be small enough to produce product that meet the standard required. In the previous video, we learned that and we try to find out the assignable variation of a process and we try to remove that one. But here in the process capability, we concern a lot about the natural variation of the process. The natural variation of the process should be small enough. It should be meet our standard. The process that is statistically in control, the process that is statistical control doesn't necessarily meet the design specification. This means that the process in control, there is possibility, even though the process is in control, there is a possibility that that process doesn't meet our requirement, doesn't meet our expectation, which is represented in the design specification. This is because in the process capability, in the specification, we include the natural variation. It is determined by the natural variation. So the process capability is the measure of relationship between the natural variation. So I should highlight this one, the natural variation of the process and the design specification. The way we measure the process capability, we have two kind of measurement in measuring the process capability. The first is what we call it the process capability ratio or CP. CP, capability ratio, defined by upper specification, not upper control, but this is upper specification minus lower specification divided by sigma, where sigma is the deviation of the population. A capable process, the process that we say this is capable have the CP at least or at minimum 1. And here, this process capability ratio, it couldn't measure whether the process is in center of the specification range or not. So there is a kind like a rule of thumb that said if we have a CP 1.33 is used, this is to allow the process off center. But for Six Sigma quality, this is required 2.0 at minimum. For the process, for the good process, the center process. Take a look at this simple example about the insurance claim process. We know that the process mean is equal to 210 minutes, where the standard deviation is 0.516 minutes. So the design specification in this case is 210 minutes plus minus, this is 3 minutes. So let's calculate the capability ratio. The upper specification limit minus lower specification limit, in this case 213 minus 207 divided by 6 multiplied by sigma, which is 0.56, so equal to 1.9. Since this is above, yeah, or equal to 1, so we can say that this process is capable. As we already discussed before, that the capability ratio cannot measure the center, cannot show whether the process is in the center of specification or not. One measure that able to do that is, we call it the capability index, or CPK in this case. This is the formula for the CPK, which is the minimum of upper specification minus X bar divided by 3 sigma, or in this case, X bar minus lower specification limit divided by 3 sigma. Again, this is the same with the capability ratio, which is the capable process. We said the process is capable where it has the capability index at least 1. The capable process, the capable process in this case, it falls within the specification limit at the both extreme. Take a look at this example. We have the new cutting machine that has the average of cutting 0.25 inches, and the process standard deviation is 0.0005 inches. The upper specification limit is this much, and this is the lower specification limit. So we can simply calculate the capability index for this is resulted in this number, 0.65, which means this process is not capable. What happened with the process that is not capable? So we need to find out, we need to find out the new way in making our process is capable. For example, if this machine is naturally works in those range, so we should buy a new machine or renovate this new machine. Okay, well, how we can interpret the CPK, based on this situation. Let's see. If CPK is negative, it means the process is out of the specification. So this line represents the specification. 0, it means that the center of the process is either at the lower or upper specification limit. If the CPK is between 0 and between 1, so the center of the process is in between the center of the specification and the upper or lower specification limit. CPK equal to 1 is the center of the process, so exactly at the point of center, the point in between the upper and lower specification limit. And the CPK, capability index, more than 1, it means the condition is the same with the CPK 1, but having lower deviation. So it means low sigma. Sigma is much smaller than the previous one. I hope this information, together with the example, give you an insight about how we can measure the process. So when we use this measurement, after we already define that the process is in control, and then we should use both capability ratio and capability index to measure whether our process is capable or not to meet our requirement. Thank you so much, and see you again in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.